This video is the extension to section 2.7 in your book. It is over evaluating compound or piecewise and step functions. Okay, so a compound or a piecewise function is defined by at least two equations, each of which applies to a different part of the function's domain. So basically, it's a function made up of pieces. This is what a compound or piecewise function might look like. You've got at least two. You could definitely have more than two equations, but each part has a limitation on the domain written after it. And so this one would be the line 2x minus 1, but only for the parts where x is less than or equal to 1. So it would just stop when x equals 1. And since it's equal to, it would stop with a closed circle. And then we would graph the line y equals 3x plus 1, and we would start it at 1 with an open circle and then go on to the right for all the x's greater than 1. So two different pieces. Okay, so here is a problem for you guys to do. I want you to evaluate the function g of x equals 4x minus 3 for all x is greater than 3, and g of x equals 5x plus 2 for all x is less than or equal to 3, when x equals negative 2, and then when x equals 5. So we're going to do this twice. And I want to point out that whenever we have our compound or our piecewise functions, this is going to be greater than and this is less than or equal to. They'll never both be equal to, because if they were both equal to, then the function would overlap, and then it wouldn't be a function anymore because overlapping is not allowed. So when x equals negative 2, the biggest mistake that I always see for people doing these types of problems is they'll plug it into both of these and give me two answers. But they're saying when x equals negative 2. So you just have to pick the situation that applies to. Is negative 2 greater than 3? Or is negative 2 less than or equal to 3? And it applies to the second one. So we're going to only plug it into the second one. We're going to plug 5 times negative 2 plus 2. Gives us negative 10 plus 2 is negative 8. Now, when I say x equals 5, again you have to think which of these applies to it. Does it apply to the first one or the second one? When x equals 5, 5 is greater than 3. 5 is greater than 3, so we use the first equation for x minus 3 with x being 5. So 20 minus 3 is 17. Each one only has one answer. Each one was from a different piece of the function. But if you have more than one answer, you've got to remember it's not a function if you have more than one y. So you have to just look at the x, look at which piece it applies to, and then only plug it into that one. Okay, here's another example to try. This time we're going to graph the function f of x equals x for all x is less than negative 1, x plus 1 for all x is between negative 1 and 2 inclusive, and negative 1 for all x is greater than 2. So this function will have three pieces that we're going to graph. And when you do that, it will look like this. So the first part is y equals x for all x's less than negative 1. So right here at x is negative 1, we have an open circle, and then this is the graph of y equals x. If you were to continue that out, it would have, slope of 1 and y-intercept of 0. But we're not. We're stopping it right here when x is negative 1. The second part of the function is the line y equals x plus 1, so that one has a y-intercept of 1 and a slope of 1. But we're stopping the left end at negative 1 for x and the right end when x is 2. Closed circles on both of those because of the equal to. And then y equals negative 1 is just a horizontal line, but we're starting at x is 2 and going on to the right with an open circle here going on to the right. Alright, and then with this same example, now let's find f of 2. So that means, where does 2 fit in? 2 is right here. So that's on this line, right here. You can also just look at it if you hadn't graphed it and say, well, is 2 less than negative 1? No. Is 2 between negative 1 and 2 inclusive? Yes. Is 2 greater than 2? No. So you know we're going to plug it in to x plus 1, and y equals 2 plus 1 is 3. And if you look right there, that's 3. So f of 2 is 3. The function evaluated at 2, when at x equals 2, is 3. All right, here's another example. We're going to graph the function f of x equals -4 for all x is greater than or equal to 2, and x squared minus 8 for all x is less than 2. So for all the x is greater than or equal to 2, we're just going to have y equals -4, a horizontal line. And then for all the x is less than 2, we're going to have y equals x squared minus 8, which we know from the other day, talking about transformations. That's a parabola shifted down, the vertex is shifted down 8 units. But we're only going to show the part of that parabola that exists for all the x values less than 2. So it should look something like this. Y equals -4, but only for the x is greater than or equal to 2. So we'll start at -4, 2 with a closed circle. And we're going to have a horizontal line infinitely that way, to the right. And then f of x equals x squared minus 8. We know that the vertex of this parabola moves down from 0, 0 to 0, -8. 1, 2, 3. There. And then we know when x is 1, y is going to be -7 and -1. When x is 2, we've got this point right here. When x is 2, 2 squared is 4 minus 8 is -4. So our open circle is going to overlap this closed circle. And that's okay. It fits right into itself, so it is still a function. And then it mirrors to this side. And you can just sketch in your parabola, put an arrow to show that it keeps going to the left. And that is what this function looks like. And now, if I asked you to find f of -3, you say, well, -3 is less than 2, so I'm going to use this one. And -3 squared minus 8 is 9 minus 8, which is 1. So when it's -3, we have a point here at 1. You could have put that in your graph if you wanted to. So find f of -3, we found it. It was 1. Okay, here's your next example problem. This one says write a piecewise function for the graph shown. So we'll start with f of x equals, and then we've got 3 pieces. So we're going to have a big bracket here with room for 3 lines. All right, the equation of this line, if I were to continue it out forever, that's just y equals 2. But we started, at -2 with a closed circle, so less than or equal to x, and then on the right it stops at 0 with an open circle, less than 0. The next piece of this is y equals 1, and it starts at 0 and touches it, and then ends at 2 and doesn't touch. And then this last one is y equals 0. It starts at 2 and touches it, and ends at 4 without touching. So now we've written the piecewise function for the graph shown. If I asked you for the domain and range of this, the domain starts at -2 with a hard bracket, and then it continues. And then because there's open circle and closed circle overlapping, it still continues, and it still continues. So our domain is everything from -2 to +4, with a soft bracket on the 4 because of the open circle. But we don't have any gaps on the inside. The range, however, we do have gaps, so I'm going to change to like a darker blue. The only y values that exist in our range are 0 and 1 and 2. But nothing in between. I drew those little blue parts just a second ago, but the black part, there was no graph in between. So when we have specific values, remember we use the fancy brackets. The range is only 0, only 1, and only 2. Nothing else. Alright, so the function we just graphed is called a step function, and that's because its graph resembles a set of stairs. A step function is defined by a constant value over each part of its domain. There's no slope, it's just the constant value. And then there's different steps of the domain. That can increase, like going up, or it can decrease, coming down. It doesn't matter. Alright, and here are 2 last examples. They're basically saying the same thing, but they're worded differently. The first one says, write f of x equals the absolute value of 12 minus 3x as a compound function. And then there's a picture of the graph. The second one just says write the following function, because I might just give you a graph as a piecewise function. So I could use the word compound, I could use the word piecewise, it doesn't matter, it means the same thing. So let's look at the first one. We're going to start with f of x equals, sorry, I want a darker pen, f of x equals, and it's got two pieces. The first piece is this one. And because we know this is 12 minus 3x, this line, if we were to just graph this part of the line, the y-intercept would be 12 and the slope would be negative 3. So that part is 12 minus 3x. And that's for all x's that are less than or equal to 4. You can tell because there's 4 right there. I just covered it up. Then the other part of the graph is this part. And so we know the slope of this one is positive 3 because it's just the opposite of the other side, 3x. And then you can count down until you figure out where your y-intercept is. But if you do that, it's just going to be the opposite of 12. It's going to be minus 12. So 3x minus 12 for all x's that are greater than 4. Notice that I put the equals on the top one. I could have put it on the bottom one as long as I only have it on one and not both. That's the compound function. So the second one, it's easier to figure out just by looking at it. F of x equals. And then if we looked at this line, this part of it, it's got a slope going down 2 and over 1. So negative 2x, and its y-intercept is at negative 1. And that's all of the x's to the right, so I'm going to say greater than. And then it looks like it's crossing at 1/2, and or negative 1/2, and you know it is because you know your slope is negative 2. So up 2, back 1, that's halfway in between. So x is greater than negative 1/2. So then the other part of the line has the slope of positive 2x. And if you were to continue this up, it would cross at positive 1. And that's for all of the x's that are less than or equal to. You can put your equal to on either one, it doesn't matter, but less than or equal to negative 1/2. So you need to figure out your slope, your intercept, and then where it begins and ends. And that's how you do that. And that's all I have for you. So you guys enjoy the rest of your evening. And of course, enjoy my comic, because maybe I should grade you guys this way too, right? Yeah. Okay. Good night.